Hi class, we're looking at lesson 11.1, which is simplifying radicals involving products and quotients, so multiplication and division. Let's look at our rules to begin. We have our multiplication property of square roots tells us that as long as a and b are greater than 0, so they're positive numbers, the square root of a times b equals the square root of a times the square root of b. For example, if we had the square root of 54, 54 is 9 times 6. So we could potentially take the square root of 9 and multiply it, that's multiplication there, times the square root of 6. And we know the square root of 9 is 3, and the square root of 6 we would leave in simplest radical form as a square root of 6. So the square root of 54 simplified is 3 root 6. You might remember last year when you talked about simplifying radicals, you took out all perfect square factors. We'll talk about what simplest radical form is here below. With the division property, again, as long as a and b are greater than 0, we can take the square root of any fraction and we can break it into the square root of the numerator over the square root of the denominator. So if we had the square root of 16/25, we could take the square root of 16 and divide it by the square root of 25, and that would be left with 4/5. So what is simplest radical form? Simplest radical form follows these three rules. A radical expression in simplest radical form where all three statements are true. The radicand, so that means the radical house, has no perfect square factors other than 1 inside it. The radicand does not have a fraction in it, so you take that fraction out by taking the square root of the numerator and the square root of the denominator. And then the final requirement is that the denominator does not have a radical sign in it as well. And I'll show you how to rationalize the denominator here in an example. A radical expression is basically a simplest radical form expression in which all three of these are true. So let's look at what it means to simplify a radical. Here in our first example, we have the square root of 28 times x to the 7th. So we could potentially break this down into the square root of 28 and the square root of x to the 7th. And this would all be multiplication here. Now the square root of 28 is 7 times 4. So we could take the square root of 4 and we get 2. And then we get the square root of 7, which is just 7. Now over here at x to the 7th, you'll see that we have x to the 6th times x to the 1st. And anytime you're taking square roots, you can divide the exponent of the variable by 2, and you get x to the 3rd coming out, and then you're going to have 1x inside the radical. So we have these two products that we can combine to make 2x to the 3rd times the square root of 7x. Please in class make sure you ask about Mrs. Mona's rules for radicals and dating. They are very similar. Let's look at multiplying two radicals together. So we can see here we have 12, square root of 12 times the square root of 32. Well, 12, if we put everything inside the house, 12 broken down is 3 times 4. And 32 is, anyone have it? 16 times 2. So we look here, and what perfect squares do we have? We've got 4 and 16. Well, the square root of 4 is 2. The square root of 16 is 4. And then we have the 3 and the 2 that are both prime numbers, so they are not perfect squares. So they are going to have to be left inside the radical as 6. And then 2 times 4 is 8. So we have 8 root 6 is the square root of 12 times square root of 32 in perfect square simplest radical form. Let's try the next example. I'm going to erase this. We have 7 times the square root of 5, x, times 3 times the square root of 8x. What I'm going to do is bring out anything that's already outside. I'm going to pull them out and multiply them. So I have the 7 times the 3. So I've taken care of that. Now what's going inside the radical, I'm going to bring the 5x and the 8x and bring those inside the radical. So I've got 5 times 8. They're all under one radical. And then x times x, which is x squared. Now, what perfect square factors do you see? Well, x squared, the square root of x squared is x. So that's going to come out with my 7 times 3. I've got an x. And then in the 8 here, the 8 is 4 times 2. Well, the square root of 4 is 2, correct? So I'm going to also bring out a 2 here with my 7 times my 3, my messy 3. So what's left inside the radical is the 5 and the 2 here, okay, because I've taken care of that, and I'm left with 5 times 2, which is 10. And out here, I've got 2 times 7 times 3 times x. So that's 21, 42x. So this simplified is 42x root 10. Okay? I'm going to erase this so I can work with my fraction now. In looking at my radical here, I have a fraction of the square root of 75 x to the third over x. Sometimes it's in your best interest to reduce first. Sometimes it's in your best interest to take the square root of whatever's inside and bring it out and then reduce. You have to kind of think about things and their perfect squares and their prime factorization and what's divisible. So all of your divisibility rules and your factoring rules are going to come into play, as well as all of those rules we talked about in Chapter 8. And I know that was pretty rough for some of you, so you might want to look back at your notes. In this problem here, I am going to do a little factorizing in that we've got 75, which is 3 times 25. I see that right away, okay? And then I have x to the third in my numerator. In my denominator, I've got 48, which I know to be 3 times 16, okay? And then I have this x. Now let's see what we can simplify before we start taking the square root of the numerator and the square root of the denominator. Well, anytime I have a factor of 3 divided by 3, those are going to cancel out and make a factor of 1. So that was the nice thing about dividing those threes out. Then I have my x to the third divided by x. What does that make? Well, our rule tells us we can subtract one exponent when dividing, so this is going to take and make this x squared here. Let me clean that up for you. So this becomes x squared because I had x to the third divided by x, and so I subtract one x from the power and I get x squared. So now I'm left with the square root of 25x squared over 16. Well, I can take the square root of the numerator over the square root of the denominator. Now, I've reduced and then I have the square root of 16. Square root of 25 is 5, square root of x squared is x. So I have 5x. In the denominator, I have the square root of 16, which is 4. So in simplest radical form, I have 5x over 4 is equivalent to the square root of 75x to the third over 48x. Okay? Notice I'm following all three of the rules that we talked about here. The radicand has no perfect square factors. It does not have a fraction, and my denominator does not have a radical as well. Looking at our last two examples here, we're going to have to rationalize the denominator. So I want you to think about all that we've done so far and following our rules. So our first rule says that we have no perfect square factors inside our radical. We don't, in example A. And then our second rule tells us, looking back at our second rule, that we don't have a fraction. Well, we do have a fraction, but it's not the radical sign does not have a fraction. We have, but our third rule, which tells us that we have the denominator cannot have a radical. So what we need to do here is we need to multiply by 1. But again, 1 doesn't have to look like 1 over 1. We multiply it by whatever the radical is here, which is the square root of 7. So if we multiply by the square root of 7 over the square root of 7, okay, what ends up happening is in our denominator we get root 7 times root 7, which is the square root of 49, or 7. In our numerator we have 3 square root of 7. And so in simplest radical form, following our rules for rationalizing the denominator, we multiply this fraction by root 7 over root 7, and that simplifies down to 3 root 7 over 7. Now here in B, again, we're going to do the same thing, but before we do that, I'm going to take out the factor of 4 and an x squared here, okay? Because I know that 12 is the square root of 3 times 4, and then x to the third is x squared times x. So what ends up happening when I start to simplify everything out is I end up getting the square root of 11 in my numerator still, and then I have 2x times the square root of 3x, which is left inside the radical. Okay, see, our 3 and our x are both prime numbers, so they cannot come outside the radical. So now I have to rationalize my denominator, and again, I'm going to multiply by whatever my radical is here in the denominator. So I'm going to multiply it by the root of 3x over root 3x. So in my numerator now I have 3 times 3x, which gives me 33x. In my denominator now, I have this 2x, don't forget about this 2x, but then I have root 3x times root 3x, which when you take the square root of that, that becomes 3x out. And so I have 2x times 3x, and again, following our rules for variables and exponents, I can make that 6x squared. So in my numerator, I have 33x, and in my denominator, I have 6x squared. And then just your final step is to make sure you can't reduce anything else out. We'll be practicing this a lot in class, so please make sure if you're writing any areas of confusion, any VIPs that you see are very important, make sure you're writing all of those down so we have them to discuss in class. Go ahead and try the quick checks, and when you're done, you may check your answers. So here in example 1, when it's all said and done, we have negative 2a to the 4th root 15a. In example 2, we have 26. In example B, we have 15c root 2. In example 3, when it's all said and done, we are simplified to 3x. In example 4, after we rationalize the denominator and reduce, we're left with root 3. And then finally, example B, when we rationalize the denominator, take out all perfect square factors, we are left with root 10t over 6t. Again, please write down your questions and we'll discuss in class. Thanks.